All right, welcome to lecture 28, part B. In this part, we're going to talk about making up solutions again, but not the way we talked about in lecture 27. All right, so with that, let's go ahead and get started. All right, so we're going to talk about making up solutions again. Now, I already know we kind of already talked about it. When we talked about it before in the last lecture, lecture 27, we talked about how, hey, you can take a solid, you can dissolve it in water, and you can make up a solution. So what we're going to talk about in this part, though, is let's say you already have a solution, but you don't like the concentration of it. You want to make it a different concentration. Now, to be specific, you want to make it a lower concentration. So if you want to make it a lower concentration, that means you're basically going to dilute it. And when I say dilute it, that basically means you're going to add water to it. So you're going to add water to some solution to make it less concentrated. All right. So you might do this all the time around your house even. You might have some juice or something and it's too concentrated. And so you add water to it and you make it a lower concentration after you add the water. So in this case, we kind of tell because with this juice, like if it's less concentrated, you can see it's like a lighter color, a less intense color. All right, so one concentration, we want to make it a different concentration. Well, what we're going to figure out in this part is, well, exactly how would we do that? What amounts do we need to use? So for this kind of idea, taking one concentration, making it a different concentration, the way we figure that out is this equation. C1 times V1 equals C2 times V2. Now in this formula, the ones are what you have, the twos are what you want or what you're making. So C is your concentration. The concentration I have times the volume of it I have will equal the new concentration times the new volume. All right. So this is going to allow us to figure out if you have one concentration, usually we're talking in terms of molarity, one molarity, and you want to make it another molarity, how would you exactly do that? All right, so let's do an example. Let's do a little example here. Let's get into a little math. All right, so very commonly, if you work in chemistry or biology or some other, science field, when you order a chemical, they might actually already mail you a solution, but they might mail you a solution that is way too concentrated. Like for example, when you order, I guess this is sulfuric acid, they ship you a bottle, and the bottle has a concentration of 14.8 molar. Now that concentration is actually really high. It's really, really potent. So you really wouldn't want to deal with that molarity if you didn't have to. So often to make a lab work, to make a chemical a little safer to use, we're going to take that concentrated bottle of sulfuric acid, that 14.8 molar sulfuric acid, and we're going to make it a lower concentration. So let's say I wanted, instead of 14.8 molar, I wanted 275 milliliters of 0.5 molar sulfuric acid. 275 milliliters of 0.5 molar sulfuric acid. How many milliliters of the concentrated stuff would I use? So we're going to get out a container. We're going to measure some of the concentrated, the 14.8 molar sulfuric acid. We're going to measure out some of the 14.8 molar sulfuric acid. We're going to put it in our container. Our goal when we're done, we want to end up with 275 milliliters of stuff, and we want it to be 0.5 molar. So how much out of the concentrated bottle would we use? All right, well, we're going to have to calculate it. So the equation to help you out is C1 times V1 equals C2 times V2. The ones are what you have. I have 14.8 molar sulfuric acid. I'm not sure how much of the stuff I have to use. I'm solving for that volume. How many milliliters would you use of it? I am trying to make, I want 0.5 molar sulfuric acid, and I want to make 275 milliliters of it. So I'm trying to create 0.5 molar sulfuric acid. I'm trying to create 275 milliliters of it. So if I want to see how much I need to use, I think I'm on the right track. Now I just got to get V1, I should say, by itself. To do that, a little algebra time. Let's go ahead and take both sides and divide by 14.8. Oh, I like that, because the 14.8 over on the right is going to cancel. Left, I should say. And you'll be left with this. The volume I need is going to be 0.5 times 275 divided by 14.8. Now, if you type into your calculator and work it out, you should get 9.3. 9.3. Oh, let's double check. Got to have a unit. Let's see. Molarity cancels. 9.3 milliliters. All right, so out of that concentrated bottle, you're going to have to get 9.3 milliliters of stuff. All right, now the whole goal is to make it less concentrated. So you're not just going to use the concentrated stuff, you're going to have to add water to it. So the second part of this question says, well, you told me how much to get out of the concentrated bottle. How much water do you mix in with it? So how much water would I use? Now, the way to figure that out, it's actually not a bunch of math, or not an equation at least. If you want to know how much water we're going to use, well, remember again, we want to create 275 milliliters. So if 9 of those 275 are the concentrated stuff, whatever's left, the remaining stuff, that's going to be your water. So the amount of water, the way we would figure that out is we just need to subtract. You subtract 9.3. Now, when you subtract, you're going to get 266. All right. So you would use 266 milliliters of water, mix it with 9 milliliters of the 14 molar sulfuric acid, you'll get your solution, your half molar solution. Now, if you're wondering, did he round it? Did he do that part right? I think I did here. I know we haven't done this in a while, so maybe I should mention it. When you're subtracting, you go by decimal places, 0 digits after the decimal, 1 digit after the decimal. You give me the least amount, 0 digits after the decimal. You should have 0. All right, with that, let's do another one. All right. So we have one concentration. We don't like it. Make it a new concentration. I don't like you, 14 molar. Make it a different concentration. All right, let's do another one. All right. Your lab has a solution that's 12 molar hydrochloric acid. Hydrochloric acid, that's HCl, by the way. 12 molar, that's actually what you buy if you ever buy hydrochloric acid. They'll mail you 12 molar hydrochloric acid. For a set of experiments, you need 2 liters of 1.5 molar hydrochloric acid. How would you prepare this? So you've got a really high concentration right now. That's what you own, 12 molar. You want to turn it into 1.5 molar. All right. If you're taking one concentration and you want to make it another, you can use C1 times V1 equals C2 times V2 to figure it out. All right. So let's see where these numbers fit. Your lab has a solution of 12 molar. The ones are what you have. I have 12 molar. That's my beginning concentration. For an experiment, you need 2 liters. That's the volume I'm trying to make. Of 1.5 molar. That's the concentration I'm trying to make. And it's asking me, how would I prepare this? So really what I mean by that is, how much of the concentrated stuff are you going to use? So the way you would figure that out is you would get solve for V1. Does that look right? I think it does, right? The left side is what I have. I've got 12 molar. I'm trying to turn it into 1.5 molar, and I want 2 liters of it. All right, so yeah, this looks good. Now we're going to solve for V1. So to solve for V1, what would you do mathematically? Divide by 12. That's what you would do. All right, is that going to work? I think so, because the 12 cancels and you get V1, which equals this. Now, if you work it out, 1.5 molar times 2 liters divided by 12 liters. Oh, I wrote the wrong unit there, didn't I? 12 molar. What you come up with? You come up with an answer of 0.25. 0.25. Now, wait a minute. What unit's on that? 0.25. Oh, molarities cancels. 0.25 liters. All right. Now, as far as that goes, what have we just calculated? The V1, I know, but what is that telling me? That is telling me how much of the concentrated stuff to grab. Out of the concentrated bottle, like, this isn't it, but I don't have hydrochloric acid sitting around my house, believe it or not. But, you get out of this bottle, out of the concentrated bottle, you're going to get 0.25 liters. Now, that's not all you're going to grab, right? You also have to grab some water. So if it says, how would you prepare this? You've told me how much of this stuff to get. How much? Well, the other thing I need is the water. How much water would I get? How much water would I get? What's the answer to that? How much water would you need? Keep in mind you're going to make 2 liters. Oh, 2 liters, that's the total volume. So if 0.25 of it is coming from here, the rest of it is water. So you should subtract 2 minus 0.25. You get 1.75. So that's the amount of water. All right. So you would use 1.75 liters of water, 1/4 of a liter of my hydrochloric acid. You put it together, you get your 2 liters, and it's going to have a concentration of 0.5 molar. All right. Hopefully it's making sense. You know what? Let's do one last one that's just a little bit different. Let's do one more that's just a little bit different. Let me flip over to it. All right. All right, our final example on these lines. All right, so in this one, I'm going to give you a little warning. The way I've set it up is slightly differently. So one thing I want to remind you of, or I want you to get used to is, the way a question is phrased, you got to really think through what I'm telling you and what you're going to do with it. Because not every question, are you told the same exact information in exactly the same way, right? All right, so let's read this question and let's make sure we're reading it carefully. If concentrated hydrochloric acid is 12.4 molar and you have 455 milliliters of it, what would be the concentration if you add 500 milliliters of water to it? If concentrated hydrochloric acid is 12.4 molar and you have 455 milliliters of it, what would be the concentration if you add 500 milliliters of water? All right. This has something to do with molarity, has something to do with adding water. It sounds like to me, I need to use this equation. We have a solution, we're adding water to it. All right, now, the other thing I'm going to do is, now I'm pretty sure that's going to be the right equation. Now, while we're doing it, let's go back and read it, and let's try to figure out where these numbers go. And the other thing that kind of helps me at least is I'm going to keep drawing those pictures, the ones over on the side here. Like, here's our container. All right, let's see what we're doing. I have concentrated hydrochloric acid, which is 12.4 molar. So that's my original concentration. And I have 455 milliliters of it. That is my original volume. All right, so in this container, we have 12.4 molar hydrochloric acid. There's 455 milliliters of it. All right, that's what that's told me so far. Let's keep reading. What would be the concentration after we add 500 milliliters? So now I'm going to pour in 500 milliliters. What would be the concentration after we add that water? I am solving for C2. What's the concentration after you add the water? Now this is where you got to be a little careful. On the right-hand side, I'm solving for C2. I need to know on the right-hand side, I got to plug in there V2, the final volume. Is the final volume 500? No. See, this time, the way I phrased it, I made you do something a little bit different. The final volume, how much stuff are you making at the end? You got to add it together. The final volume is not 500. You're adding in 500 milliliters of water. So in total, 500 and 455, we are going to end up with 955 milliliters of stuff. V2 is what you're making. You are making 955 milliliters of stuff. All right, how do I know to do that? Well, it comes from just reading the question carefully and making sure you kind of think about what you're doing. What are you physically doing? And maybe drawing a little picture wouldn't hurt you either, huh? All right, so let's go ahead and now that we have everything in the right place, I think that was the hard part. Now the math is just like before. Go ahead and solve for V2. You would divide by 955. Oh, why? Because I want that to cancel. If you do it on the right, you got to do it on the left. And so you get C2 equals 12.4 times 455 divided by 955. Now, if you bust out your handy-dandy calculator, you type it in. C2 equals, what do you get? 5.91 molar. All right, so you'd end up with a solution just under 6 molar, just a little bit less than 6 molar. All right, with that, that's it for this one. There's one more part to this video, part C. We're going to talk about another concentration unit. So if you're sick of talking about molarity, well, you're not going to talk about molarity in the next one. We're going to talk about something else. Let's get to it. Part C coming up.